Hi, my name is Tristan Watkins. I'm head of service architecture for security and networks at IT Lab Group. And I'm going to talk to you a bit about the challenges of supporting users' own devices on Windows and other home computer operating systems, for lack of better description, Mac OS and Linux as well. We find that people come to the bring your own device topic with an expectation that the behavior will be the same across all platforms. And this session is really about diving into that topic in a bit more detail to understand where it's different between the most prevalent mobile operating systems and the most prevalent kind of desktop operating systems. So briefly, we'll talk a little bit about what approaches are common for home working. So the first approach is probably the most traditional one, which is to issue a corporate machine to a user, a laptop typically, and then that machine would be usable wherever that user is working, potentially on a customer's premises, at home, internet cafe, etc. And the controls that you would use to secure that device in those different contexts will vary depending on the organization's appetite for risk. So some organizations might decide to prevent connecting to untrusted networks, say to prevent a man-in-the-middle attack at an internet cafe. Would be an example. And other cases may be a little bit more permissive about that specific risk. One way or the other, what you get with a corporate issued machine is the ability to fully control what is allowable from a security and compliance point of view. And that's really what we're talking about. So things that you might commonly see on that would be a VPN for accessing resources on the corporate network, although increasingly we are less reliant on that capability. And you would see that this corporate issued machine could be any platform. It could be Windows, Mac, iOS, Android, etc. And really, the challenge in the current situation is that this doesn't necessarily adapt well to kicking off this experience when a user hasn't had it before, when they're at home and nobody is there to support them. So we are working with a number of organizations that are, say, transitioning from Windows 7 to Windows 10. And as part of that, we might be intending to deliver the operating system via autopilot. So we can even ship a machine to the user at home and have them start using it with the corporate kind of controls in place from the moment that it boots up. But the additional challenge is that if a user isn't accustomed to Windows 10, there might be some additional training and adoption necessary to make that experience a good one when they first receive the device. So this isn't necessarily going to solve all problems, and also not all organizations can actually take this approach. They don't have this funding. They haven't got this in their budgets, etc. So the second kind of most common approach to allowing people to work from home or other locations is to let them use their own mobile device. So typically an iOS or Android device these days. And this works really well. We have really established and reliable controls in what was known as mobile application management, or is now known as Intune app protection capabilities, and those align well with the conditional access capabilities in Azure AD. So we can say that if you are signing on from an untrusted network on iOS or on Android, that we're going to allow you to connect so long as you're using what's called an approved client app. And all of those approved client apps can be protected using Intune app protection policies. So we're sort of funneling the requirements through this check. Yes, you're using one of these apps that can be controlled. If you choose to control the app, we apply those controls as well. So it's both access control and application management. And that, as I say, gives us really good way of extending this remote working experience to mobile devices in a secure way, which gets users access to their email, to their OneDrive, to Teams, Yammer, etc., in a secure way that is very easy for them to just pick up and start using without having to do things like connecting a VPN, for instance. So there's a very popular way of doing things, but the really important part about that for this topic is that those controls are not the same outside of the iOS and Android world. Those controls do allow us to do things like, say, blocking, copying, and paste out of one application into another, or out of a corporate container into a personal container. And I'm not going to spend a lot of time talking about that right now, but as I say, very good and reliable way of doing things on the mobile platforms. Third approach, which was common for a long time and is less common these days, and not something we really endorse, is to allow users to use their home computer. And what I mean there is that we're not managing that machine. It is the user's own machine, and we're just going to let them have access to the corporate resources. Say we're not using conditional access to require device compliance or an improved client app. We're just going to let them sign on. And there's a lot of risks that come with that that are generally unacceptable. So devices could be infected. The user might be able to leak data from that machine. They might be a shared device. It could be an untrustworthy network. And ultimately, you put all of these kinds of risks together. That's just some of them. And what we really see is that there's no way to determine that the machine that we think is a home computer actually is a home computer. So irrespective of all those specific risks that might apply to the home computer, we don't actually know that it is one. It could be an internet cafe terminal. It could be a malicious user who has stolen that user's credentials and is signing on from their own machine. Ultimately, because this isn't a managed machine and there's no process for testing to what that machine is that we can trust, it could be any machine. And so that's why that approach is really fairly weak from a security point of view, and we don't typically endorse it. And the last approach I'll talk about here is basically you can require VPN access to corporate resources, and even say you'll restrict access to your cloud resources to your premises, but you'll allow users to connect to your premises via VPN, and then they can gain access to cloud resources in that way. And ultimately, in isolation, that's kind of just security theater. All of the risks that I was talking about above still apply to that device. We've just required that that user go via VPN. But once they're connected via VPN, that device could still be infected. If there is malware on that device, the malicious user that's there could potentially take screenshots, have access to the microphone, the video camera, all manner of things on this device, which has got access to both the corporate network and to those cloud resources that we're locking down in that way. So ultimately, I don't think that this is a valid way to control access in isolation, but I do think that it can be combined with other approaches if what you're really worried about is accessing corporate data that is on your network. But as I say, that is less of a firm requirement these days as people have moved things to cloud services. And so ultimately, I think it's kind of a distraction from the main question here. So you put all of that together, and this is kind of why we arrive at the position where security is saying no. And that's a big gulf of expectation between what Microsoft is setting up an organization to expect when talking about BYOD and what the reality is when it comes to security getting involved and saying this is or is not acceptable. So I'm going to spend the rest of the session really talking about why we can't have BYOD on Windows or Mac or Linux in the same way that we can have it on iOS and Android. But also, so a bit about why that is, but really where that leaves us and where there is actually a good solution to this problem, I think, in session controls. And that's provided through Cloud App Security. And I'll really finish off talking about that. So to dive in a little bit into the question about why this isn't working in the same way on Windows is really that we don't have this app protection capability on Windows in the same way that we have it for Android and iOS. What we do have is Windows Information Protection, or WIP. And WIP can be configured for enrolled or managed devices or unmanaged BYOD devices. It does provide application level controls about how you can copy and paste data between applications, whether you're allowed to remove that information from the device, etc. But they are kind of and they are application scoped rather than system level. So it's not like a group policy that blocks you copying onto USB. It is scoped at specific applications. But the real major difference here is that this is telling us what we can do with an app on a device rather than how we can gain access to a service, a cloud service, for instance, in the first place. And that access controlled decision has a great solution for iOS and Android, which is this require approved client app condition in conditional access. And that does not exist for Windows. It does not exist for macOS, and it does not exist for Linux. So ultimately, we can do something that will get us control over the apps on any device, but we can't say that you must have that in place in order to gain access. And this is the thing that is really poorly understood. This is the thing that ultimately changes what you can do in the BYOD world for those other operating systems compared to iOS and Android. So that's really the main point of this, right? That's where we say, okay, so now what are we going to do? So we can look at other access control options that we have in conditional access. I'm going to really quickly go through those and just talk through why those don't solve this problem. So first is requiring MFA, and requiring MFA is great. You should be doing it, but it's only securing a user's credentials. It has nothing to say about a device. We can require hybrid or AD join, but that's really only suitable for corporate devices. So, the reason you can't do that on a user's own device is they wouldn't be able to sign on to it after you revoke their account when they leave the company. So it's very, very obviously not suitable. And then you can require a device to be marked as compliant. And that is kind of viable, but not in all cases. So what that means is that we must have an enrolled device. So a user must say, yes, it's okay for my organization to manage my device. Now, that comes with things that the user needs to accept. And those trade-offs historically were unacceptable. So we would say that the organization can wipe my holiday pictures. And that would be the end of the discussion. HR would get involved in that conversation and say, nope, we can't do this. This is not an acceptable way to manage our users' own devices. Because they could have a legitimate complaint after they leave the organization. So different organizations had different attitudes towards that, but it was generally not a popular approach and didn't have a great success rate. But over the last year, both iOS and Android have changed their MDM capabilities to allow a better selective wipe experience. So it is more viable these days than it was. But I do want to caution people that users still may be reluctant based on prior experience to accept those conditions. And some of the conditions are actually going to change what they need to do, like putting in a PIN for certain things, or accepting stricter device controls. And for many users, they simply may not be able to bring their device into compliance. And so if this is a time where they need to be able to work on their own machine at home, and we're not talking about iOS and Android, then this may not be viable for reaching all employees. So we do need to think about what alternatives to that look like. And that final alternative is session controls. So I will come on to that in a second. Really want to talk for a second about why this is such a different problem, because I don't want this to be seen to be tainting Microsoft or any of the other, or Apple for macOS or Linux. I don't want this to be seen as a blanket criticism. Really, what we have here is that iOS and Android, by virtue of the fact that they've come along later in the day, have had the ability to introduce an application sandboxing requirement that we can't retrofit onto the other platforms as easily. And that app sandboxing approach has been tried in Windows. We had it with Windows RT. We have it today with S Mode. We had it in Windows Mobile. And ultimately, it's not for lack of effort and not for lack of trying to solve this problem in that way. It's that it simply hasn't been very popular. So Microsoft continues to work at this. S Mode has now got some new capabilities that might make this more acceptable in future, put together with Defender application control. But as it stands right now, it's not how most organizations are operating, so it can't really solve the problem. And until we get to that point, I don't think that Microsoft really feels that putting forward a solution for app protection on Windows with Win32 apps is really an assured solution. Because the fact is that the Windows API is open enough that you could have any manner of malicious things, either a malicious user or a hacked device, basically interacting with that application in ways that we can't control in the same way that we can with a properly sandboxed environment. So that's kind of why this thing is the way that it is. And I don't think we can really expect that to change anytime soon, unless organizations move towards S Mode with the new Win32 capability. That's something I'm very keen on exploring more, something I'm spending a lot of time on, and I'll try and update you on that when I have a bit more to say about it in future. So for now, we're going to come back to the session controls point. And really, session controls are a reverse proxy capability for Azure AD authenticated SAML2 and OpenID Connect applications. What that basically means is if the application has benefited from single sign-on in Azure AD, either by creating a SAML trust or an OAuth trust. OpenID Connect is the user authentication extension to OAuth 2, known as modern authentication. So if you have one of those apps, these are well documented by Microsoft, which apps those are, then you can basically hand off to the Microsoft Cloud App Security reverse proxy. This is called Conditional Access App Control today, but it's basically the MCAS session proxy. And that allows you to restrict what a user can do when accessing that service on an untrusted device. So if we bring that back to the Windows world, we're on somebody's untrustworthy Windows device, we will give them maybe a read-only view. So we block the exfiltration paths of download, cut, copy, and print on that device. Or maybe we take a slightly more permissive view of things and we say we're not going to fully block it, but if you are accessing sensitive information on that device, we're going to protect that information with rights management when the user downloads it, but only on that untrusted device. We're not going to do that for all users in all situations. We're going to balance this difference between a trusted device, a corporate device, where that won't happen, and this other set of controls that kick in on the untrusted session. We can prevent uploading unlabeled files that contain sensitive information. So when the file goes up, we check to see if it, say, got PII or credit card information. And if it doesn't have a label on it, we can we can block the file from going up there and tell the user they need to put a label on it in order to be able to upload it. We can monitor sessions just to meet audit obligations in this untrusted context and say to capture information that'll help us build out other controls in future. And then you can block custom activities as well. We won't talk about that a great deal right now. But the upshot here is that we don't have to simply say no. Security can say yes, but with caveats, and that's what session controls offers us. We can also get a bit more granular inside the session control policies to say that user agent blah has this experience relative to these others, and you can really get into the weeds there. It's not my intent now to give an educational session on session controls. There's a lot of good content out there on it. There's also app-enforced restrictions, which are similar, but only apply to Exchange Online and SharePoint Online. Big difference here is that app-enforced restrictions are available with Azure AD Premium P1, and Conditional Access App Control is only available organizations that have Azurity Premium P2 plus MCAS. So that's really an EMS E5 customer typically. There's a lot to say about session controls themselves. Really just wanted to sort of explain the case for them and why they're really quite important, I think, today in the COVID-19 era, if you will. Hopefully it doesn't become an era, but it might be around for a while that we're working like this. My colleague Mike Parker has a post up on practical365.com, which we'll try and share along with the post for this, about how to configure CloudApp security to protect Exchange Online. And that's just a good example of one of the apps that you might choose to do that for, say OA. And one of the real examples of where a user might want to hop on to a Windows machine and just start using OA there real quick, maybe to set up a calendar appointment that is maybe more difficult to set up in the exact right way on the mobile app. And so instead of saying, no, you can't do that, we will let them do that on their home machine, but what we won't do is allow them to download information from Outlook web app if that information is sensitive. So hopefully this is a useful session. I'll try and do some more over the next couple of weeks, share our thoughts on some of the Microsoft Cloud security technologies. I hope this was useful. Cheers.